Welcome back and hope you are excited as we continue our wonderful journey in additional mathematics. My name is Nana Yawedu. You can call me Ise Nana. In our previous lesson, we have looked at the commutative property and we've considered an example where we are able to determine whether or not an operation is commutative. Please ensure that you practice more, solve more questions, and then you share this video, like this video, comment on this video, and ensure you subscribe to my YouTube channel so that you can get all the videos on time. In this lesson, we are going to basically look at another property of binary operation, which is the associative property. So let's consider the associative property of binary operation. So basically with the associative property of binary operation, we are considering having two elements and introducing another element. So we can say let A, B, and C, which belongs to the set of real numbers, right? So we have A, we have B, and then we have C. So we say a binary operation, this time we are using a triangle as an operation symbol, defined on the set of real numbers R, is said to be associative if A and B and C, as we have here, A, B, and C, right, is a member of the real number system, and we say that A operation B, so the first two, we put them together, and then operation C, we say is equal to, we pick the first one, and then operation, put the next two together, so B operation C. So we can use probably real numbers to be able to understand it better. So for instance, if we have 2, 3, and 4, and we say these three belong to the set of real number system, we can have 2 plus 3, to bracket, plus 4. And we say that can be equal to picking the first one, 2 plus bracket open 3 plus 4. Now we see that when we have 2 plus 3, it gives us 5. And 5 plus 4 will give us 9, right? And then when we have 3 plus 4, it gives us 7. 7 plus 2 as well will also give us 9. So we see that the operation here gives us 9, and that here as well gives us 9. Therefore, this is associative. So now that we have understood what an associative property is, let's consider a question on associative property. So the question here says that a binary operation, and the operation symbol is a circle with a star inside, is defined on the set R of real numbers by A operation B to be equal to AB plus A plus B. And we are to determine whether or not the operation is associative. And then we are also to evaluate for operation 3, operation 2. Now let's consider a solution for this question. So the question is A, and remember the operation sign is different. It's this operation sign, operation B. And that is equal to A, B plus A plus B, right? So in our A, to be able to solve the A, we would say that for associativity, we know that our A operation, let's use the same operation symbol. So operation B, we put the first two together, operation C, right, will be equal to, now pick the first one, operation, put the second and the third together, right? We can say where A, B, and C are a member of the real number system. So now we can consider the first part, which is A operation B. Now we know that A operation B is already here. It is equal to AB plus A plus B, right? So it means that we can put this into brackets. And then now we know that in the first part, which is A operation B operation C, right? Wherever we see A operation B, we can represent it with AB plus A plus B, right? So we are going to have AB plus A plus B, which is representing A operation B, and then operation C. So operational C here, right? So what this implies is that wherever we see A, we must replace it by AB plus A plus B. And then wherever we see our B, we replace it by our C. In the operation here, A operation B, which is AB plus A plus B. So now let's look at what we get there. So that means that we are going to have AB plus A plus B, and then the B is now C, so multiply by C, plus AB plus A plus B, and then this one as well plus C, because this is for the A here, and then the C here is for the B here, right? So now we want to expand this. So our AB plus A plus B operation C will be equal to, when we expand, means that we multiply A times B multiplied by C, so it gives us ABC. Then we have plus multiply A times C, which gives us AC. Then we have multiply B times C, which gives us BC. Right. Then we'll have AB, and then A plus B, then plus C. We'll call this equation 1. So we can rewrite this as A operation B, the 2 in bracket, operation C, which is this part of the equation, to be equal to ABC plus AC plus BC plus AB plus A plus B plus C. Now this is equation 1. Now let's look at the other parts where we have A first, operation B, operation C. So we want to consider B operation C. So it means that wherever we see A, we'll put B there, and wherever we see B, we'll put C there in the operation here, right? So it means that we are going to have our B operation C to be BC plus B plus C, right? So this now represents B operation C. Now we are going to put that in place of the B operation C here. So we'll have A operation BC plus B plus C. Now this time, note that our A now maintains our A, and then our B will now be replaced by this whole thing, which is BC plus B plus C in the operation here. So let's perform that operation. It means that with that, we are going to have A operation B, C plus B plus C to be equal to A multiplied by BC plus B plus C, right? Then you are going to have plus A plus BC plus B plus C, right? So we would want to expand this, so it means that we will have A multiplied by BC plus B plus C, which will be equal to ABC, right? So we are going to multiply A by B and C, so ABC plus AB plus AC, right? And then we will have our A, which is here, and then we will have our ABC, right? So we have our BC, right? Then we will have our B plus C, right? So we can call this equation 2. So now that we've been able to get equation 1 and equation 2, we want to compare the two equations to see whether we have the same thing. So check this. The first one, we have ABC for equation 1. Let's check if equation 2 also have ABC. So yes, equation 2 also has ABC, so that is checked. Now let's check. Here we have AC. We want to check whether there is AC here, so there is AC here, so that is also checked. we have BC. So we want to find out whether there is BC here, there is BC here. So that is also checked. We have AB. So we want to inspect whether there is AB on the other side. We also have it there. And then we also have our A. So we have our A here. We have our B. We have our B here. And then we have our C. And then we have our C here. So we've exhausted all of them. And we've realized that they all belong here. And then they all belong in the equation 1 as well. So we can say that since equation 1 is equal to equation 2, then the operation is associative. So we can conclude that the operation is indeed associative. Now let's consider the B part of the question. So in our B part, we've been asked to evaluate 4, operation 3, and then operation 2. So we'll first have to look at the one in the brackets for operation 3. So we know our 4 operation 3. We are putting it in the operation A operation B is equal to AB plus A plus B. Right. So it means that wherever we see our A, we can put our 4 there. And wherever we see our B, we can put our 3 there in the operation here. So that will give us 4 multiplied by 3 plus 4 plus 3. So it means we have our 4 operation 3, and that is going to be equal to 4 multiplied by 3 gives us 12, plus 4 plus 3 gives us 7. So we have 4 operation 3 to be equal to 19. Right, so once we have our 19, now we are going to pick our 19, which replaces our 4 operation 3, and then we multiply it by operation 2. Right, so we have 19 operation 2. So we are putting this into the main equation again. So wherever we see our A, we have to replace it with our 19. And wherever we see our B, we replace it with our 2 in the operation. So that means that we're going to have 19 multiplied by 2 plus 19 plus 2. Now 19 plus 2 give us 21. Then 19 multiplied by 2 give us 38. So 38 plus 21 will end up giving us 59. So it means that we can say that our 4 operation 3 operation 2 is equal to 59. So basically in this lesson we have looked at the associative property, and you can realize that in solving associative property you will need to really take your time and go through the variables, because there's an introduction of a new element apart from the A and B or the X and Y. You have to introduce a C or a Z so that you'll be able to determine whether or not the operation is associative. In the next lesson, we are going to look at another property of binary operation, which is a distributive property. Ensure you like this video and subscribe to my YouTube channel. See you in the next lesson.